Hello, everybody. Today we are going to figure out how to find the sum of an infinite geometric series, an infinite number of terms. So you're going to be adding an infinite number of numbers. Isn't that amazing? Let's see how we can do that. So here's example one. Here is a geometric series, and we know it's geometric because there is a common ratio. Our R value, which can be found by taking, let's say, term 2 divided by term 1, or maybe term 3 divided by term 2, is 4 over 2, which is 2. So this is geometric because the common ratio between every pair of terms is 2. So the next one would be 32, because 16 times 2 is 32. And this can go on forever. 64, 128, etc., 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 all the way to infinity. Okay? And what we want to know is if we added all of these terms, all of them, even the ones way over there, what would it add up to? And you can see that the sum of an infinite number of terms, that means infinity. I didn't draw my 8 sideways or anything. The sum of an infinite number of terms here would be infinity. Bow tie, okay? It would be a very big number. But not all geometric series will equal infinity if you add all the terms up. Let's check this one out. Here we've got another geometric series, and R here is term 2 over term 1, 1 over 10, or if you prefer a decimal, 0.1, right? Same with here. 0.1 divided by 1 is 0.1. This divided by that, 0.1. And so these numbers go on and on and on forever, just like the last one. And the common ratio between subsequent terms is 0.1. Now let's see what happens when we start adding these numbers together. So sum of the first two terms would be 11. If we add the third term, it would be 11.1. If we add the fourth term, those four terms together is 11.11. The sum of the first five terms, 11.111. Sum of the first six terms, like that, 7, 8, 9, 10, 11, 12, all the way to infinity. So no matter how many terms we add here, we're never going to get to, let's say, 11.2. We'll never get past 11.111111. Okay? Because there's an infinite number of decimal places that we can fill up, and each term fills up one more decimal place. Okay? If we wanted to see this graphically, okay, here's our series, and if we wanted to find the sum of the first term, that would be just 10. And if we would add a second term, so two terms, we'd get 11. Sum of the first three terms would be 11.1. Sum of the first four terms, 11.11. And so the sum of an infinite number of terms, you can see that this thing flattens out, and it converges to a finite number. So this one, it's not going to approach infinity like the other one. Okay, so there is a formula we can use to find the sum of an infinite number of terms, and it works when R is between -1 and +1. And in this case, we're in luck. And here's our formula. Term 1 over 1 minus R. and our first term was 10. And then we've got 1 minus our r value, which is 0.1. And so we've got 10 over 1 minus 0.1 is 0.9. Okay. So that's the formula. And 10 divided by 0.9 divided by 0.9 is 11.111111, etc. So 11.11 repeated. Okay, that is the sum of an infinite number of terms in this series. Okay, have a good day.